Let's see if SIPP Essentials is a good fit for your training requirements. In this 5-day class, we'll take a look at the SIPP protocol. We'll take a detailed look at the grand picture, all the components, how they all fit together. There's lots of labs, lots of graphics to make the picture clear. Each chapter will follow this format. We will begin with the vocabulary that we'll use. This vocabulary is probably not necessarily part of your vocabulary, so we'll make sure that we're not using any terms that you would not be familiar with. We also define them straight up at the beginning of each chapter. There's lots of pictures and diagrams that will describe the concepts. We're not big into text slides like this one. We actually like to use diagrams of things. We always focus on the big picture before we do the deep dive into the protocol. We want to make sure you understand how the protocol is going to fit into your environment, into any environment for that matter. There's lots of labs, but the labs are directly applied to the topics that we are covering. Furthermore, we're using all freeware, so you can replicate these labs at home or at your lab at work, and you can also use them to test interoperability and all kinds of possibilities, as you may decide when you choose to actually put them in production, at least for testing. We always finish each section with review questions. Now, Chapter 1 basically focuses on everything. We cover all the topics in this one chapter that the whole course will ultimately provide. We want to make sure that you possess the grand picture of how all the components are going to fit together. This is the time to make sure that if you're comfortable with the voice side, but the data side is new to you, we make sure that that's understood. If telecommunications is somewhat foreign to you and you have a strong datacom background, we're going to speak both your languages in this chapter. Make sure there's an understanding of how voice over IP functions, particularly under the control of session initiation protocol. Our emphasis is always on concept and proper use of vocabulary. We identify all of the boxes. When we're finished, you're going to clearly understand the big picture. Let me show you an example of one of those slides that we actually see in the first chapter. Now, this is one of many that we use to describe interoperability. This is an example of a SIP call setup that's interoperating into the public switch telephone network. Let me explain this one just like I would if we were in class. Our A party, which is originating from 717-566-4428, is calling 215-555-1978. Ultimately, the call setup is going to be hopping across this path where this portion, at least that far, is going to be public switch telephone network. The remainder of the signaling path is going to be SIP. We'll talk about the interoperation right here. This is where the magic is going to occur. So our originating party goes off hook. We have 30 milliamps of current flowing, and our user dials this phone number that you see over here on the right. So after the digit 9-215-555-1978 is dialed, a setup message is sent from the PBX to the end office. Now, the setup message contains the calling party's number, the called party's number, and also the channel that the call is on. Now that the end office knows this information, it must make an autonomous decision based on this information. The decision that it makes is part of its routing table known as the dial plan. It has its own dial plan. It did not learn the dial plan from telephone switches that are adjacent to it like you would in an IP network where OSPF or EIGRP, some other interior gateway routing protocol, would have told it. That is not the case. In this particular case, a human being has to tell this switch how to route calls, and the entry then made as a static routing table. In this particular case, let's say that our end office chooses this as the best path, and it has 200 inter-machine trunks to choose from. Let's assume that none of those trunks are busy right now. Well, our end office was provisioned to know that Signaling System 7 point code 3.5.9 is how to talk to our next tandem switch. So an initial address message is sent. The initial address message specified is going to destination 3.5.9 from the originating point code 3.5.2. A signal transfer point, which looks more like a router really than a telephone device, simply responded to the destination point code 3.5.9 and relayed the initial address message to our tandem switch. Because it too is configured with a static routing table, but this time the static routing table is for point codes. It's not for telephone numbers. So now our called telephone switch, the third one in a row, now knows the originating party's number, the terminating party's number, and it also knows that the call is on channel identification code 19. It must make a routing decision based on its dial plan, and its decision is to send an initial address message to our next telephone switch. Well, to our tandem switch, it thinks the next telephone switch is a PSTN, or Public Switch Telephone Network, TDM switch, and using Signaling System 7, the message is sent to 3.5.3. And now our first switch that begins the voice over IP network knows the originating party's number, the terminating party's number, and it knows the calls on channel identification code 22. Now it's time to talk about these little termination points. These little termination points are known as a termination. Specifically, these are physical terminations, and they are patched together with a logical or a digital patch cord so that these two terminations interconnect in a context. So we'll have a context right here. There'll be a context in the PBX. And in fact, right now we have 3.5 of them. But we begin the SIP networking now. The session initiation protocol invite is sent first from our tandem switch, is really what this yellow switch is, to a back-to-back user agent. This would be a feature server that happens to know the whereabouts of our called number because prior to this end user registered. So the IP address or the domain of our destination is known by the feature server. The feature server simply relays the SIP invite to where the registration came from. Now a session border controller is going to make modifications to the invite, making it appear as though the invite originated from the outside of the session border controller. What you should know is that a session border controller has two interfaces, one facing in, which usually has a private address, one facing out, which has a public address. So when the invite arrives at the session border controller, the session border controller completely rewrites the invite, making it appear as though it's brand new, popping out the outside interface, effectively deceiving the called party into thinking that the call actually originated from the session border controller. And this is exactly the way we want it. This allows the session border controller to hide the rest of the network from our outside called party. So we would have an untrusted and a trusted side of the session border controller. Now there's another thing you should know about the SIP invite, which originated here and ultimately relays to the destination. The SIP invite contains session description protocol. Now, session description protocol is describing a termination, a special kind of termination known as an ephemeral termination. This is where RTP traffic is going to originate and terminate for this phone call. This termination, again, described by session description protocol, must be attached. All this information that's contained in SDP must be attached to the SIP invite. So when the SIP invite, effectively backpacking session description protocol, passes through the session border controller, the session border controller rewrites session description protocol, making it appear as though the ephemeral termination is on the outside of itself. This is going to cause our called party to send voice to the border controller. The called party will never send voice into the soft switch, which has an embedded media gateway, because it does not know about that. In the response to the SIP invite, the called UA responds ultimately with a SIP 200. This indicates that the call was answered, and most likely this contains session description protocol. I say most likely because there could have been a 183 response prior to this that would contain session description protocol. We don't know that right now. So let's just skip to we've answered the call and session description protocol describing this end is passed back. Well, session description protocol describing this end is backpacked onto the 200 response, which effectively backtracks the path that the SIP invite has taken. So ultimately, the response makes it all the way back to the soft switch with embedded media gateway. This is going to permit voice to travel from the media gateway to the border controller, from border controller to destination. So we actually have two separate ephemeral pathways, from the media gateway to the inside of the border controller, and from the outside of the border controller to the called destination. The border controller will patch these two ephemeral terminations inside of itself, forming a context which was created completely under the session border controller's control. Now, in all of this, please understand the session border controller is forcing itself into this particular call to make sure that it hides the inside from the outside and also the outside from the inside. By making it become an RTP relay, where RTP is the voice, not the signaling. And it also is a session initiation protocol back-to-back user agent. This is a special kind of a SIP device which has complete control, not only routing, but originating, terminating, and any other aspect of the call which it wants to modify in any way it certainly can. So we would look at the control plane as from soft switch to a back-to-back user agent, from back-to-back user agent to border controller on the inside, from border controller on the outside to our called UA. The media path is going to be coming on the outside to border controller on the inside to our originating media gateway. The soft switch in this case is not interested one bit in hearing what is being said. It only wants to control the setup and teardown of the call. So now that the call is actually in place, we have this blue path, if you will. It's all the way back to the originating party. And the control path, which I'll remind you using the red color, is the ISDN Q931, the signaling system 7 messages, the SIP messages that you see was all part of the control plane. And in this particular illustration, we have a clear separation between the control plane and this blue stuff, or the bearer. The result would be that voice packets start to form just like this. So we see samples coming in at 8,000 samples per second. Enough samples are captured until we have an adequate amount. Normally 20 milliseconds is the favored amount. So we capture 20 milliseconds of sound right there and then pass it onward towards the destination. This particular flow is showing call information, showing the voice going in this direction. We're not showing the voice going in the other direction for simplicity, but believe me, it would be occurring. So there you have an example of how SIP, RTP, Session Description Protocol interoperate with the public switch telephone network. We have other examples just like this one to show other call scenarios in an attempt to make it crystal clear the big picture of how SIP interoperates within the public switch telephone network. We'll do the same with presence, we'll do instant message, and just about everything else that SIP is controlling these days, even video. In section 2, we're going to cover the SIP architecture. In SIP architecture, we'll make sure you understand what a user agent is, what a proxy is, what redirect, forking, back-to-back user agents, and back-to-back user agents not only for feature servers and routing, but also back-to-back user agents for security, otherwise known as session border controller. We'll talk a little bit about the IP multimedia subsystem, or the IMS, just so you know that SIP has a huge role to play in that, and it's a good way to understand the SIP architecture. We'll talk about RTP, RTCP. These are the media channel and the media QoS reports. Session description protocol is discussed very lightly in here, enough to understand the architecture. In more depth, we will cover the SIP methods, such as register and invite, ACK, refer, buy, cancel, and so on. Make it very clear what each one of these particular SIP methods or SIP requests do. We're going to cover the SIP responses. Now, these are the numeric responses that come back as a result of a request. So if we send an invite, we expect to get back some sort of provisional response, like a 180 or 100 or 183, and then ultimately a final response. That would be a response greater than or equal to 200. During this particular section, we're also going to talk about via, route, and record route. This continues on into the next section because SIP manages the SIP dialogue in a very clever way. The actual decision as to how to set up the SIP dialogue is done in the SIP invite. All subsequent messages take advantage of this, where SIP is effectively follows the rule of route once, switch many. In the next section, we're going to talk about SIP URIs. You have to be able to read them. This section doesn't take long, maybe about 15 or 20 minutes, but we will talk about, first of all, the definition of a URI versus URL, and then specifically how to read a SIP URI. The colon, the semicolon, the @ sign, question marks, all those special characters, how to read SIP parameters, both for a domain parameter as well as a user parameter. We'll apply this not only to a SIP invite, but to presence, instant message, and registrations as well. If you ask us to cover certain vendors, like you might be interested in how is Link doing, or how is Avaya doing it, or how is Cisco doing it, it's all good to us. We do not study a protocol like Session Initiation Protocol just for one particular vendor. We work with all of them, and we like all of them. They're all good to us. In our next section, we're going to take a close look at Session Description Protocol. Now, SDP, you'll recall, describes the ephemeral termination. It takes two Session Description Protocols in order to set up a SIP call. SDP can only describe one end. Therefore, we need SDP from the A party, we will need SDP from the B party. The exchange of Session Description Protocol is done using a process known as offer-answer, which is part of the media negotiation. You need to clearly understand how that works, not only because it will greatly help in configuring it, but if you do have to troubleshoot, typically it's not SIP that's the problem. It's Session Description Protocol. There are 7 key fields that you need to understand in SDP. Just about all problems solved if you know them, and we're going to cover them in great detail. The next section talks about DNS. Well, in SIP, when we are transmitting a SIP message to a domain, which is not understood by a proxy, because you see, when a proxy receives a message like a SIP invite, the first thing that it does is it looks for the @ sign. Now, to the right of the @ sign is going to be a domain. What if the domain does not belong to the SIP proxy? Well, in the previous version of SIP, RFC 2543, it would simply discard it, and this was known as strict routing. It would throw the invite away. It wouldn't process it. But in the new version, RFC 3261, which is what, some 12 years old now, it's a different story. There is an interesting DNS process, NAPTR, serve, and A-record queries that will allow a SIP proxy to relay a message to the proper destination. It's extremely well designed. You'll enjoy this chapter. It's one of our students' most favorite. In the next section, we talk about ENUM. Well, this is an extension of the DNS, and it's at a perfect place in the course because once we understand the DNS, we can study how to take a phone number, effectively write it backwards, put an E164.ARPA suffix on the end, do a DNS inquiry, which will make sense after studying the previous chapter. The results will be the destination domain. This means you could take any phone number, convert it into a domain, and relay the SIP message to the appropriate destination. Very cool, and we cover the whole mechanism in ENUM. Predominantly in the enterprise, configuration of phones is done with DHCP. Now, SIP has its own DHCP options. We will cover them. This chapter is going to last a whole 10 minutes because No vendor's actually following it, but we will cover other vendors and their mechanisms on how to configure an endpoint to know outbound proxy and proxy for registration. In our next section, we will talk about interoperating SIP with the legacy public switch telephone network. So we'll look at how will this work into a QSIG environment? How does this work into signaling system 7 or public switch telephone network? How about if I'm just interoperating into a PRI? What does this do to the way that SIP works? And it turns out there's some serious consideration. SIP has solved the problem, or I should say people now understand it. SIP always could solve the problem, but we're starting to deploy it properly these days. You need to understand what a 183 is. We need to define what call progress means, and ultimately, I'll tell you right now, it means that the progress tones are in the media path, which means you actually have to listen with your ears to determine what's going on, because the signaling protocol is not going to tell you. In this section, we'll also study SIPP. For those of you more involved in the public switch telephone network side, this is a big deal to you. We'll cover that here. In the next section, we talk about RTP. This is the media path. So RTP is voice over IP. RTP is how we encapsulate voice, make sure that we timestamp it, add a identifier, like a microphone identifier that identifies who's talking. There's other fields that are involved so that when the RTP encapsulated voice arrives at the destination, it can be played back as if the person were standing there right in front of you in real time. We create the illusion that over an asynchronous network, we actually provide synchronous information. RTP has the magic tool to do this. It's known as a timestamp. De-jittering can occur because of this. We'll explain that mechanism. Now, it might be important that you track how well RTP is behaving. There's a protocol for that. It's known as RTP Control Protocol, RTCP. Now, RTCP, if you choose to run it, will add another 5% of overhead to the voice call, but as a result, you will know at the end of the call how well the performance was. We'll learn packet loss, latency, and jitter from this, and in this chapter, if you don't know what that is, we'll explain that as well. In our next section, we're going to take a look at DTMF. This is an extension, actually, of the previous chapter. The subject was simply too broad to pack it into the RTP chapter. When we dial digits, we're actually creating two tones simultaneously. This is dual tone multi-frequency. There are problems using DTMF across a network that is using some compression algorithm like Speaks or G729. If you're using compression like that, the DTMF tones are damaged. You should learn signal-to-noise ratio, twist, amplitude, and other issues that are causing the problem, so that when you dial into voicemail or you call an auto attendant, and no matter how hard you dial, how long you press the buttons, you can't get the other end to respond. We'll explain exactly why that's the case. And the solution is, well, you could switch back to G711. You could use RFC 2833 or SIP info. RFC 2833 is sort of an example of, rather than actually send a recording of the tone, it's sort of like we send music. So it said we're playing a half note of a C and a half note of an E. Play that particular third chord at the other end, and that's an example of RFC 2833. Now, in the SIP info message, we say, well, we're playing a 4-digit. We're not going to tell you what the duration of it is. This works. It has advantages. There's a lot more. We'll cover that stuff in this chapter. In our next section, which oftentimes is optional, students either care very strongly or they don't care at all regarding fax handling. We'll address this in a number of ways. If we have 2 or 3 students that feel very strongly about this chapter, we might just push it all the way to the back and they can hang around to the end of the course, and then we'll cover that. If we're all interested, or maybe we want some degree of it, we'll cover it. We can go to whatever depth you want to in fax handling. We'll at least cover T30 and T38 and RTP relay using G711. In our next section, we're going to cover presence. So presence is a combination of instant message, whether you're logged in or logged out. It's all based on XML or text or HTML of some kind markup for making our text messages look really cool and add the smiley faces and all that sort of thing. Oftentimes, I note that when students take this particular section, they're thinking that presence is like Skynet or something like that, and it's going to keep track of what we're all doing. And that's not really the way the protocol works, although certainly it could. There's nothing stopping it from doing it that way. It's more of a relay service, so that if your status changes, you would include that in a SIP notify or a publish message, relay it on to a present server, which relays it to anybody who cares, and they would have described that they cared using a SIP subscribe. So we'll explain exactly how that works. It's a fun chapter. It doesn't take very long. To understand presence, once you understand what a SIP dialog is, believe me, it's probably the easiest chapter in the course, once you understand how SIP works. In our next section, we talk about SIP timers. SIP is designed to work over UDP. Therefore, if a SIP message for some reason is dropped in the IP network, we need to retransmit it. Well, the only way to handle that is we need some sort of acknowledgement coming back, so we need to know how long do we wait around before some message comes back before we try again. And if we do try again and we still don't get a response back, well, then we retransmit, but then how many times do we retransmit before we just completely give up? And it turns out it depends on the SIP method. This section is going to cover that. Also in this section, we're going to talk about the session expires timer. This one is primarily of interest to mobile carriers. These are people that are in the cellular business. It's possible you do a battery pull, you drive through a tunnel, go over a mountain or something like that, and you no longer can keep track of the guy there. They're just gone. But the mobile network would think that they're still on a call, and the call would stay nailed up. So there needs to be a way to establish a heartbeat to make sure the person's there. That's the session expires timer, and we'll take a close look at that. We have a great section on SIP security. Now, the SIP security section is going to cover all of the details regarding TLS, actually PKI, a symmetric key, an asymmetric key. We're going to get into RSA. We'll talk about certificates. We'll talk about fake certificates and how you should deploy a PKI infrastructure if that's your plan. We think you should understand a lot more of the mechanism than perhaps you had bargained for. I think it's more than just copying root keys and things like that. You should understand the mechanism. And ultimately what you should understand is, after all the work, is it really secure anyhow? Now, we're white hats, we're not black hats. I suppose we could be the bad guys if we'd want to, but that's not our plan whatsoever. So we're going to show you how to keep the black hats at bay. We don't teach hacking. That's not something that Alta3 does. In our next section, we'll talk about NAT Traversal. It's at the perfect time in the course because at this particular time, we have covered Session Description Protocol, we understand RTP, we've taken a look at SIP, and it turns out that in order to avoid the classic one-way voice syndrome which NATs cause, we need to put some sort of mechanism in place to make sure that voice gets through the NAT. Well, there's several different mechanisms. There's stun, there's turn. We're going to cover ICE. Now, these mechanisms actually extend beyond SIP. If you're studying the new HTML5 stuff, particularly on media from browser to browser, they're using the same techniques. And we try to do that in all of our courses. We just like technology sometimes just for its sake, especially when technology bleeds into many other environments. We're going to make sure that you understand that's the case. And in this particular case, NAT Traversal actually is impacted by a lot of different technologies. If you understand it, you're not going to have one-way voice, at least not from NATs. In the next section, we're going to cover SIPP. Now, this will be our last section It's a great chapter to end up with. This is a big hit for quality assurance people or for testers or people like that, because SIPP is the perfect tool to test your SIP environment. So maybe you're saddled with testing to see how many hundreds of thousands of calls per second your SIP proxy can process. Maybe you're trying to replicate a problem to see if you can come up with some sort of solution. Maybe you're just trying to understand the SIP protocol. Any one of those possibilities, SIPP is a perfect thing. It was given to us by Hewlett-Packard. They did a great job with it. There's SIP-ER, there's SIP-SAC, and there's other tools which we will use in here. But we like SIPP the most because it's XML-based, it's easy to modify, the students pick it up quickly, and of course it's free. So you can use it in your environment for testing. Finally, we have some really nice labs. They're listed in the bottom of the page. If you just look right down there, we have them all listed. Shown here, I'll give you a few of the highlights. You're going to set up a SIP lab. We're using Camelio, and then we'll use Asterisk. We use Camelio because we need a SIP proxy to illustrate the difference between a SIP proxy and a back-to-back user agent. Most of the course begins using Camelio, which, if you've ever used this, you realize this is not an easy proxy to get operating. But it's extremely powerful. It's carrier grade. It measures capability in the hundreds of thousands of calls per second. We've tested it. We're impressed with this product. It's just not for the average bear. You need to understand the protocol well to use this. But I promise you, as a result of this class, you won't be afraid of Camelio, and you may even decide to use it at certain places in your network. We'll use Wireshark. That will be our primary tool for decoding. We'll show you the Wireshark tricks in order to decode voice, SDP. We'll take a look at SIP. We'll take a look at how to do flow graphs and telephony services graphs that we can weed out certain SIP messages. We'll show you which particular fields make sense to filter on. Finally, we'll take a look at T-Shark and how you can use T-Shark to do SIP probes all around your network. You may decide that a freeware solution might be the right one to manage SIP in your network. Near the end of the class, when it's imperative that we start to play with back-to-back user agents, we'll put Camelio aside and we'll break out Asterisk. We'll use Asterisk for a number of feature servers, for feature server applications, but primarily our interest with Asterisk is just to take a look at how a back-to-back user agent behaves. At this stage, all kinds of things can happen. During certain private engagements, we will get people that say, well, can you just show us this with Avaya, or can you show it with Cisco? Maybe you can show it with this Mitel switch that we have. We have no problem with that. We'll make it interoperate so fast it'll make your head spin. This is what we do for a living. In fact, one of the courses that we put together, the Avaya SIP trunking class, predominantly because we felt that's a product where an infusion of our understanding would really help it. You might want to take a look at that one as well. Well, there you have it. That's the SIP Essentials class in a nutshell. Hope to see you in a class soon. I'm Stuart Fieser. So long.